Hello! In this video we are going to solve irrational integrals. We are going to solve a specific type of irrational integrals. What they are called binomial integrals. In this case, it becomes a little bit more complicated because you don't need to apply only one change. We need two changes in order to solve this type of irrational integrals. Of course, we need to know at least a little bit about integration, we need to know a little bit about derivatives, and we need to know something about simplifying expressions. Okay, let's see. What is a binomial integral? A binomial integral is an integral with this shape. It's x powered a number times a plus bx powered the exponent another number, everything powered to p, as you can see here on the screen. Where n, m, and p could be rational numbers, not integer numbers. Could be rational, could be fractions. What does this mean? We are dealing with nth roots, okay? Could be square roots, cubic roots, or this type of integrals. So be careful. Looking at the shape seems not dangerous at all, but okay, be careful because when we introduce square roots there, it's going to be difficult, okay? So, how do we solve this integral? Let me remember that the main step is to call this element here, x power m, we are going to call it t. This is the first change, and it's always the same. We never change this change, okay? So, the idea again is to forget about a, forget about b, p, x to the n. Okay, the important part in the first change is x to the m. So we call this t, and then we continue. What we obtain later depends on where do we have an irrational term, and then we will change this into something rational. Let me show you an example, and we will deal with what happens after the first change. Okay, as you can see here, what do we have? We have the integral of x squared times 1 minus x cubed powered 1/3. The first warning, I have seen this many times. Please don't do that. 1 minus x cubed powered 1/3, this is the cube root of 1 minus x cubed. The tempting thing is just, okay, perfect, then this is 1 powered 1/3 minus x cubed powered 1/3. What I'm saying is, please don't separate it now, okay? It's not true that this parenthesis powered 1/3 is 1 powered 1/3, this term powered 1/3. That is not true, okay? And makes the exercise wrong from the beginning, okay? So we have here assume a subtraction inside a square root, a cube root. Stop. We cannot do anything here, okay? We can just solve it by different ways, but please don't split it, okay? Because this is wrong. Okay, once the warning is given, then let's see. The first change, as I told you before, is just to take this x cubed and call it t. For sure, if you solve for x, then this part becomes t powered 1/3. And the derivative of t powered 1/3 is piece of cake. The exponent goes down, and I subtract 1 to the previous exponent. So this is what I just did here when we calculate derivatives. So 1/3 goes down, and 1/3 minus 1 is minus 2/3, okay? Differential of t. Now what we are going to do is to change x by t powered 1/3. The differential of x is going to be changed by this expression, and we are going to put it in here. So what do we have? That expression. You can just go back and my advice is just do it by your own, okay? Don't just trust me, okay? Just write it and try to do it by your own. So you will learn much more than just listening to me, okay? So what we have is this. I just changed x by t powered 1/3. X was squared, so it's just t powered 2/3, 1 minus t. Remember that this is just the change we are applying. The x cubed was t, so I just replace it by t, and the differential of x is here. Okay, I hope you see that we have t powered 2/3 times t powered minus 2/3. Then when we are multiplying powers with the same base, the exponents add. Okay? So the idea is that t power 2/3 times t powers minus 2/3 is equal to t power 2/3 minus 2/3. That is 0, so t power 0 is 1. So this appears. This term and this term disappears. 1/3 is written outside. So the new integral we need to deal with is that one. Okay, 1/3 times the integral of 1 minus t power 1/3. We still have a cube root there. I need to eliminate this 1/3 exponent. And the second change is logical. I'm not going to apply a really strange change. What I'm going to do, if I want to eliminate this 1/3 because it's an irrational integral, I don't want to work with irrational integrals, what I'm going to do is to call 1 minus t c, another variable. But c power, you tell me, 3. Okay, because 3 times 1/3 disappears. Okay, so the idea is to change this by c power to the denominator of the exponent, always. Okay, I'm going to call this another variable. For example, c, I'm saying c, power to the denominator of the exponent. Let me show you. Okay, this is the change, 1 minus t, c cube. In this case, if you solve for t, then t becomes 1 minus c cube. So the derivative of t is differential of t. The other part is we're calculating differentials. And on this part is 3 goes down and I subtract 1. Where this negative comes from, because there is a middle step that I just didn't write here, is when we solve t. This c cube comes here and t goes to the other part. And that is the reason the negative appears, because it is 1 minus c cube. So then we apply this change in the integral, and 1 minus, remember, 1 minus t, give me 1 second, oh yeah, sorry, give me 1 second, let me go back here. I'm going to change this by c cube times 1/3 disappears. And I think I made a small mistake in here. This is not well written here. This 3 disappears, okay? Or if you prefer, this should be written like c cube power 1/3, okay? Then it simplifies. This 3 is not there. Please don't look at it, okay? So I just replace everything. So I obtain c times 3 times c squared. C squared times c is c cube. This 3 goes outside, simplifies with the other 3, and the final integral is piece of cake. It's a polynomial. Integrating this is nothing. So the integral of c cube is c to the 4th power divided by 4, and we are done. Okay, we are done. Stop here. We need to undo the 2 changes we have applied before. So we are going back. The last change I apply is that one. If I just solve for c, then this becomes the cube root of 1 minus t. And also, t was changed before by x cubed. So if I just replace x cubed here, my new integral becomes that expression. Complicated expression? Yes, but as usual, the integral is already solved, and this is what we wanted. Okay, so what have we seen in this video? We just solved a binomial integral. They can be difficult, but we just learned 2 changes, or how to apply 2 changes to simplify the expression. And as you saw some seconds ago, as you have seen some seconds ago, it's an easy integral, okay? So I hope you find this helpful, and thank you for your attention.